Hi, this is a hopefully really short video about our first programming assignment in assembly language class, an assignment called Key. This will be an assignment that you're going to be doing individually. Uh, we'll help you out if you need it. The teaching staff is available on Piazza and through office hours if you need some help. But we're mostly interested in giving you a chance to practice the assembly language we've talked about on your own and showing us what you understand yourself. This recorded lecture is just a short video to kind of give you a overview of what the assignment is. Be sure that you don't skip reading the assignment yourself. Down under our programs section of our webpage, there's a full description of the assignment. And that's really what you should focus on for making sure you understand it. So be sure you read that. You may even want to look at parts of it more than one time, just to make sure you don't make any mistakes. But as an overview, you're going to be writing a little assembly language program that reads keyboard input from the user and prints out some of that input to the DOS window, to the terminal. And here's a summary of what it's going to do. The user is going to type in keys. As they type in capital letters, you're just going to print those out to the terminal just like the user typed them. If the user types a lowercase letter, you're going to convert that to uppercase and print it out. You're, of course, working with the ASCII codes for any of these characters, so converting from lowercase to uppercase is easy. You just have to do a little bit of math on the character code. If the user types a blank or a period, you're also going to print that out as is, but anything else, you're just going to ignore. And when they type a period, that's a sign for the program to exit. So that's how you'll terminate it when you're done. So for example, if the user types in hello, comma, space, testing space, 123 period, all of the letters will get printed, but you can see the lowercase ones get converted to uppercase as they're printed. The comma and the digits get thrown away because they weren't in the set of numbers we're supposed to print. But the spaces get printed and the period gets printed, and that tells the program when to end. As you're writing this program, I would encourage you to start by writing out a design for your program, maybe write a version of it in a high-level language that you're more comfortable with. That should be easy. What this program is doing is pretty straightforward. So you may want to write it in C or Java to kind of get your thoughts together on how you want to write it in assembly language. So like it says, your first assembly language program should probably not start in assembly. You should start in some language you're more comfortable with, and then think about converting the individual pieces to a few assembly language instructions each. We're giving you a little bit of help for this. If you look on our Moodle page, there's a link called read file example, and it already contains C and Java versions of this program, or at least an analogous program. You probably don't need those, but they are there if you want to take a look at the same kind of program in a more familiar language. Now you'll be running an assembly and running this program on DOSBox. So we're pretending like we're running on a computer system from the early 80s. We're providing some files in a archive. The name of the archive is unpack.exe. Like some previous archives we've used, there's a link for it in the section of the Moodle page that talks about the keys assignment under the programs section of our Moodle page. You'll download that unpack archive, and when you execute it, it'll create several files in the current directory. Your job is to write a source file. So you don't get a starter for this. You'll be starting from scratch, but you'll be writing a source file called key.asm. And you'll write assembly language instructions in it. You'll write all the block comments we're expecting. You'll write all of your data declarations as needed. And then when you're ready to assemble it, you'll use the same assembler you used on the tools assignment. And there's a copy of the command you can run to assemble your program. That'll create an object file. Since your program's named key.asm, your object file will be key.obj. And then to get it ready to run, you'll need to run the linker on that, and that'll create an executable called key.exe. Now, when you unpack that archive, you get two programs to help test and grade your program. The test key program runs your program, so it's expecting key.exe is already there, that you already linked to build that. And it'll run your program with input redirected so that it can feed it a sequence of characters it wants. And it will log every time you run it, so you can tell how many times you've had to test your program. When it's time to grade your program, or when you're ready to submit something for a grade, there's a separate program we're giving you called GradeKey. .exe, and when you run that, it'll work like the testing program. It'll run your program, but it'll produce a report called key.ans. And this will reflect evaluating your program under some tests and measuring its efficiency and looking at the documentation in your program and making sure that you've got the kinds of comments that we're expecting in the class. And we've already talked about what we expect. That key.ans file is what you'll turn in to get a grade for the assignment. And if you look inside it, it's mostly a text file that contains a report of how you did on your program. Up at the top, it'll say how you did on producing correct output on our test inputs, and that's worth 60% of your grade. And then a little further down, it will give a report for efficiency. And this is measuring the number of machine instructions you needed to solve this problem. That's worth 20% of your grade, so you can earn up to 20 points on that. And then another 20% of your grade comes from looking at the documentation. Did you have the block comments and the line comments that we were expecting? And then you should have a report for your total grade. This is the file you're going to turn in. Like previous files, make sure you don't, if you look at it, make sure you don't accidentally change it, because that's going to look suspicious to us. So if you want to bring it up in an editor, be sure you make a copy of it and then bring the copy up in the editor. That's just some extra paranoia in case maybe your editor, if it sees a file and it doesn't like some of the formatting in it, you don't want it to go ahead and start making changes to that file, because again, it'll look suspicious to us. So be sure you don't accidentally change the .ans file that you generate, because we're going to be looking at it and expecting it to be exactly what the grading program generated. You've got a while before the assignment is due. It's due on March 1st, I think, at 5 p.m. like most assignments. It's not too challenging, but it'll be hopefully a good way for you to get started writing assembly language. Good luck with this, and I'll see you in class next week.